Welcome to Logistics Business Conversations, where we talk with key spokespeople in the logistics industry about topical issues. Hosted by Peter McLeod, editor of Logistics Business Magazine.
Welcome to the latest edition of Logistics Business Conversations. It's my great pleasure to introduce to you today Dr. Yaro Tenzer. He's the co-founder and CEO of Right Hand Robotics. Hi, Yaro, and welcome to the Logistics Business Conversations.
Hello, Peter. Yeah, thank you for the invite. I'm really excited about it.
It's a great pleasure to have you here today. To tell us a little bit about the technologies that Right Hand Robotics is involved with.
Yeah. So we, as a company, are really focusing on enabling robots to manipulate everyday objects. So this is on the technical side. But on the business side, we see a lot of people who have a variety of operations, and they really strive for, predictable fulfillment. Sophisticated operations and in variety of operations, you have a lot of touches, a lot of manipulation of items. Like you need to take an item, you need to put it in a box, you need to do something with the item. And so if you have automation that can do it predictably in a predictable throughput, it creates a lot of business value. So we are really focusing on that need for predictable fulfillment by building this automation robots basically that enable to do it.
Typically, you create the technology that right at the heart of the pig face, which is effectively the fingers that pick up items when you're item picking in high throughput warehouses, specifically for e-commerce, but I guess beyond that as well.
Yeah. So when we started the company, what we realized is that you basically have the brain, the vision, the AI that is capable of understanding the scene, understanding what needs to get done. And we really attached an arm and an end effector to it. We are being very recognized in the industry for having the suction and the fingers. Some people say the claw, at the same time, that's the visible part of the product. On the back end of it, it's really the AI, the machine vision that is driving a lot of the decision making. And, sometimes we kind of try to help understand people that the name of the company, Right Hand Robotics, it's the right hand for the right problem. So it's really the tool, the end effector tool that can be adjusted, but at the same brain behind it. So that's the name kind of insight into this.
So I guess the end game here is to create a technology that is at least equal to, or even better, greater than the capability of the human hand. So, for example, I'm presented with a case full of mixed items. My brain will automatically tell me or give me some kind of approximation what material they're made of, how heavy they're likely to be, how flexible they are. Is it too hot? Is it wet? You're going to have to try and recreate all of that using your technology.
So it's really fascinating you bring these topics because that's exactly what we kind of focused on. Throughput from our perspective, we defined by range of objects, reliable at high rate, the 3 R's. So we usually talk about range of objects, reliable at high rate, right? And what's fascinating is that, so for example, you mentioned, slippery or some kind of textures, right? So it falls into the range of objects, but at the same time, if you're trying to pick them fast, you might not be as reliable. But if you're doing it less, reduce the speed, you can actually make it more reliable. And this is where the AI comes in so importantly, is really looking at all the set of items that we have seen across, hundreds of warehouses that we're operating and really collected all this data and then seeing what worked, what didn't. Like I have two daughters and they manipulate items, and it's really fascinating to see how they do it. And comparing to robots, like the robots can learn from the hundreds of systems that are being installed and kind of what worked, what didn't. And that's kind of the beauty of the data-driven, or sometimes these days it's called embodied AI. That's exactly that.
So Yaro, as you can expect, as editor of a logistics magazine, I've been to a lot of warehouses, and one of the most fundamental ones I went to was a shoe fulfillment warehouse, and products they had to pick ranged in size from a small box to a large box and every box in between. I'm thinking, we don't need a Right Hand Robotics for that. Now today, when I go into a sophisticated e-commerce warehouse, you're seeing all sorts of materials all thrown together. I think automation loves conformity and repeatability. But when you see some of these totes with goods wrinkled in them, it's a really tricky pick. So can you just talk me through how the technology works, how it identifies and then fulfills that pick?
Yeah. And I love the fact that you hit the nail on the head with a shoebox, because shoebox problem is almost like a standalone problem compared to everything else in the warehouse, right? I'll try to explain it not in the technical terms. It might be more kind of to help listeners understand. So what the robot sees in a task, it really tries to understand what are the constraints, what are the items, what are all the options to pick the objects available. So, if you play chess, for example, you look at the board, you come up with all the strategies you can play, and similar thoughts going through the robot's brain. And what the robot does, it's really decides around what's the most reliable way to pick an item. And it can has, hundreds of hypotheses or ways it learns from the past, but then it ranks them by probability of success. So what you see the robot, in action, it really executes the plan that it thinks it has the most reliable way to succeed in picking the item. All of that, by the way, happens within 100 milliseconds. So it's really fast, right? And the fascinating things here is if the robot fails or something happens, like it was expecting the object to be slippery, and apparently it's not. Like it can actually, if something fails, it's an opportunity to learn. And that's where the beauty, right? Tying it back to the shoebox, problem. So the industry actually changing, but the previous generation of shoeboxes, the lid, they would open, right? So if you put one of these boxes on the side in a tote, the box will open up, right? And so for the robot, if it picks just the lid, the robot doesn't know it's just a lid, or it needs to be taught that it's a lid. Or, if it picks just a shoe, like say box disintegrated in a tote, like, you pick a shoe and our robots pick the shoes, no problem whatsoever. But then it's like, does it need to pick another shoe? Is it the right shoe? Where is the left one? So that, and that brings a slightly different, question is like, hey, what happens with the inventory that does fragile or requires kind of additional putting it together before shipped, sent to customers and stuff like that?
Your technology incorporates the sucker as well as the fingers in the same head. Is that the right terminology?
Yeah, it's the end effector, the gripper, the suction. We call it the snoot. Snoot. And the fingers. So yeah, these are. And it's really, we sometimes refer to it as a hybrid gripper. Mm-hmm. It has all these technologies, and the robot can use the intelligence to decide if to use the fingers, if to use the snoot, if to use the hybrid of this, right? Because remember, the robot, it's on a mission to fulfill the order as fast as it can, sure. The most reliable.
So the hybrid execution would be both of those functions are used simultaneously.
Potentially, yes.
So I've seen applications where it's either one or the other,
right,
and necessitates a change of head. Now, every retooling in a production line is time that's not spent productively, but the Right Hand Robotics solution overcomes that by combining the two into one head.
Correct. So what we did, we actually do have like tool changes and stuff like that, and we do change tools when needed. But you're absolutely right. We try to optimize around minimizing the tool changing time as much as possible, because every tool change is between 2 seconds to like 4 seconds, depending on what needs to be done, and that's time, right? Mm-hmm. And so what we found is that fingers is really help us stabilize the object when the robot is holding it. And so that enables us to move much faster from one location to another location. So imagine, you have to pick an item, barcode scan it, and place into one of the 6 destinations. So the fact that you can hold the object securely and transition really fast, and before the placement, means that your throughput can be much higher. And that's where the combination between suction and fingers really play into kind of the hybrid approach and your question about the range of objects.
So talking about range of objects, what are the applications where the right hand robotics technology is being deployed to its greatest effect?
Yeah, we got traction and installation across very wide range of customers. So, for example, in US, one of the key case studies is Staples. So Staples, it's not only office supplies, but we see much more kind of items that are flowing, including e-commerce items flowing through this. Some of our key customers in, for example, Sweden is Apotea. In Netherlands, Apple.com. So that's more pharma, and also they do some e-commerce, which we see. So the range of objects is really kind of office supplies. We see pharma, and more recently is apparel. So one of our flagship, opportunities is actually Hummel in Denmark, and they do apparel. And for your previous question, I was smiling because shoe boxes there is one of the things we are focusing on. And so, there we're really doing kind of, range of, apparel like items in the plastic bags to shoe boxes. So I just demonstrated, office supplies, pharma, apparel, e-commerce. So this is really broad set of things that this technology can handle.
Within that range of goods you described, I can see some problem items, or how I would describe them as problem items, which even I, as a human being, may struggle to pick up. And one of those could be, for example, a T-shirt loosely wrapped in plastic. That looks like something that hand the size of a human hand would struggle to pick up on its own. I would probably have used two hands to pick that up. So how do you create technology that could overcome that?
So that's a fascinating question. Yes, we usually, when we try to describe our product, we usually talk about one-handed person. So it's really not two hands; it's one hand, right? Because in most of the operations we see, it's really logistics. Means the item is ready, it's wrapped, it's ready to go. It just needs to be fulfilled, and we see less the need for manual manipulation, if you will. You're absolutely right. There are some, cases where it requires two hands, or the item is too big, or just hands. But most of these items don't actually go into like a standard tote or chute or something like that. And when it does, there is a case where, we don't want these items to the automatic picking station. It can manual, and the volume usually is not that big. So what we're seeing is most of the customers, they deploy our technology on 95% of their goods, and whatever the last 5% left, it will be handled in a different ways. So, for example, Staples is toilet paper, like these big things, like, you don't want to handle that as one. Or, in apparel, if you have like a really big winter coat in a kind of a plastic bag, which is not vacuumed, it's a big volume. I usually struggle to pick them up
Exactly,
myself.
yes.
So it's really not a robot case.
So the capabilities are, as you say, in most use cases, if you can cover 95% of the goods, that's a pretty good win. What are the parameters around size and weight when it comes to lifting with a right hand? So
we usually try to guide people to up to about 3 kilograms from a weight perspective. And when we talk to people, we usually say, hey, if you can pick it with your one hand, you can usually, the robot, you can usually handle that.
Typical 3 kilo item, for example.
I've seen some of the more kind of, some of the pet food, bag of protein powder, for example, can be, quite big and chunky. Yeah.
So what are the limitations of the capabilities in terms of weight and size? What does 3 kilograms look like?
So from 3 kilograms, I think we've seen items, for example, the bag of protein powder, that can be quite big. Additionally, is like maybe a jug of water or some other things which can be, more on the heavy side.
And what about size of item? Is there something? What's the smallest thing you could pick accurately?
So we have today, we are handling in production like eyeliners, chopsticks, very very small And it's really fascinating because the items are very thin. But, when you're in a tote, when you have the cameras high above, all of this, you really need to have a very accurate, precise vision system to even see these items. So not even talking about the hand that should be, gentle and sensitive enough to handle it.
What sort of accuracy levels are you able to achieve?
So we getting into 99.99 in production, which is fascinating, right? Yeah. It doesn't mean that the robot is always successful, but when the robot, if it needs to adjust its strategy and get something done, it gets it done.
We'll come back and have another go. I was at IMHX earlier this year, and I was watching a demonstration of your product on a stand, and an item was kind of caught in the corner of a tote, and it couldn't be picked on the first run. But you've devised a way to overcome that. Could you just explain that a little bit for people who are unable to visualize it?
Yeah, this is where it's fascinating because the robot is really thinking about it from a fulfillment perspective and accuracy and reliability. So if it tries pick an item that potentially stuck in the corner with a snoot, with a suction cup, and says, hey, it's something is not working well. So the robot has the capability to switch and use the fingers to try and disengage this item, to move it to a side, to try and grasp it. And through this process is really move its location, move its orientation, make sure that there is another way it going at this item. And that's what we usually call it jumble. So the robot kind of moves it around. And sometimes you can actually see it. It takes like item with like two hands, moves into a different oriented position. And, I hope you spend enough time in the booth to see it all in action.
I guess it's just what you and I would do as human beings. We'd hook a finger down the side of it and then get our hand onto it that way.
Correct.
Tell me, was there ever a time during development of the products where you thought 4 fingers and a thumb might be the solution? For those who are unable to visualize it, it's actually 3 fingers, the solution with a sake cup in the middle. Would there be an advantage to increase the number of fingers?
So we went through many iterations when we were trying to derive this, right? And it's a fascinating balance between the reliability and the business aspect, right? Because the more fingers you add, the more complexity, the more cost, the more opportunities to break, the more need for maintenance. So as we were kind of looking through this, we were trying to, use basically data to try and, question and optimize of what will be the most reliable given the costs. And what you will see is, and it's actually, what we ended up with is really the 3 fingers. You end up with basically the thumb and the kind of the pointing and the middle finger. You'll realize that you can pick quite a lot. And I'm showing here to Peter that I'm picking objects on the table.
Yaro's using his thumb and his first 2 fingers to create a 3-pronged hand and demonstrating that actually you could pick up most objects in that style. So that's effectively the direction in which the product has been developed.
Correct. And it is not as stable as, like, for example, holding with 5 fingers, of course, but at the same time, like, we are not using, when we pick an object, we really pick it and place it, right? When we, as humans, when we use 5 fingers, we sometimes use, for example, a pen or something else. We really use it as a tool.
You manipulate it within the hand, and,
Correct.
You're pressing a button on the end
Correct.
with a thumb, and you're turning it around.
And this is not really needed in a robot manipulation.
No, up
today.
and down.
Today.
I see.
Like maybe when it's outside the logistics warehousing environment, maybe there'll be opportunities down the road, but in the logistics fulfillment aspect, at the moment, it's not necessary. What really fascinates me is really the human brain, and I think that's where our inspiration is coming, because we as humans are so good at utilizing tools. If you're a restaurant, you can see how people use a fork and a knife, or switching to chopsticks, or using some other tools, right? So we as Right Hand Robotics are really kind of trying to think the same way. Is like, how can the end effect is just a tool, and how we bring it all together. So the human brain, that's what really fascinates me.
So you've got a doctor in your name. What are you a doctor of?
So I did my PhD at Imperial College in London, and visiting IMHX was really highlight for me, being back in the UK, and getting a bit of visibility into logistics in UK. And during my time at Imperial College, I really focused on sense of touch for surgeons. So when you are working on a surgery in a teleoperating matter, how much of the sense of touch is important to communicate from a robot that's doing the procedure to the surgeon who is trying to sense it, some tissue and stuff like that. Naturally, that's where I kind of gravitated after all this research. Is like, okay, how much sense of touch, how much, tactile feedback and other things are important in manipulation, and some of the work we are doing at Right Hand Robotics.
Sounds fascinating. As we reach the end of this edition of Logistics Business Conversations, I wanted to ask you, what does the future look like for this technology? Where are the big gains going to be made? Where are the challenges that you're coming up against that you hope, in the short to medium term, you'll have overcome?
So I think the future is really fascinating, because as our type of technologies are getting more adopted in the market, we'll see faster fulfillment, lights out fulfillment, right? So to give you a specific example, Staples today, they operate one shift with nobody being around our robot. If you go and, at Staples or Portia site, like the robots just work and operate. That means for the end customer that they will get their items faster. And we are unfortunately or fortunately getting spoiled by the ability just, order something online and getting it as fast as possible, right? So I think the future is really enabled by these machines, by this automation, that we can get whatever we need faster as we need it. And I think, so far, till a few years ago, this type of technology wasn't reliable enough, but now we're seeing a really big adoption starting to play out. And I think the future is where this technology becomes, integral part of the warehousing everywhere.
It's an exciting future. And I have to say, I believe we can talk about this subject for hours. Sadly, we don't have hours to talk about it, Yaro. So it just remains for me to say it's been a great pleasure speaking with you today. Thank you very much for joining us at Logistics Business Conversations. Thanks also to Right Hand Robotics for supporting this edition. And also thank you to you, the listener, for joining us today. Wherever you get your podcasts from, please subscribe to Logistics Business Conversations to make sure the next edition is delivered straight to you as soon as it's released. Until then, it's goodbye from Yaro Tenzer.
Thank you very much. I appreciate you being here. Thank you, Peter.
And it's goodbye from me, Peter McLeod. Goodbye.